So question 1. So 4 and 1/5. Rewrite as 5 times 4, 20. So 21 over 5 times 1/3 minus 1 1/4. It's 5 over 4. So multiplying two fractions, we can say 3 into itself 1, 3 into 21. That's 7. So this is now 7 over 5 minus 5 over 4. LCM is 20, so 5 into 4, 20. 5 into 24, 4 times 7, 28. Minus 4 to 20. 5, 5 is 25. So our solution will be 3 over 20. Next one, we can just use our calculator right away, and this should be 507.5. And of course, we get this by using calculator. So now we are at 1B. A stadium currently has a seating capacity of 15,400 seats. Calculate the number of people in the stadium when 75% of the seats are occupied. So a solution for this, 75% of the seats are occupied. 75 over 100 times 15,400. Or we could say 0.75 times 15,400. We end up with 11,550 persons. So next, we're told that the stadium is to be renovated with a new seating capacity of 20,790 seats. After the renovation, what will be the percentage increase in the number of seats? So the percentage increase will be the difference. Remember, the original amount was the difference, which will be 20,790 minus the original amount, 15,440, upon the original amount, which is 15,440. And within percentages, so it's times 100. So calculating 20,790 minus 15,440 would be 5,350 upon 15,440 times 100. That will be, so it's upon the original capacity, 15,440 times 100, which is a percentage. So we end up with 5,390 divided by 15,440, and that would be 34.9%. Or if you want to round off to the nearest whole number, that would be 35%. A neon light flashes 5 times every 10 seconds. Show that the light flashes 43,200 times in one day. Well, let's work out how many seconds are in a day. So we know one day has 24 hours. We know 24 hours has how many minutes? We multiply 24 by 60. 24 times 60. So 24 hours have 1,440 minutes. And how many seconds are in that amount of minutes? Multiply by 60 again. So 1440 times 60. We get 86,400 seconds. So in one day, we have 86,400 seconds. So now we want to find the amount of 10 seconds interval or in a day, amount of 10 seconds intervals in a day would be 86,400. That's the amount of seconds, right? Divided by 10, which is 8,640. Alright? I write to that light flashes 5 times every 10 seconds. So the light flashes, so therefore light flashes 5 times 8,640, which is 43,200 times. Question 2a. Factorize the following expressions completely. So the only common factor in this expression is h. So we factor h, and then now we need the terms for the bracket. So we can divide each of these terms by h. So we end up with 5h minus 12g. Notice when you expand the bracket, you get back the original expression. Next, we have a quadratic expression here to factorize. So let's find AC. AC is 2 times minus 6, which is minus 12. Let's record all the pairs of numbers that multiply to give 12. Now 12 times 1, 6 times 2, and 3 times 4. Now we need the two values where you either add or subtract to get the middle term, which is minus 1. So of course it would be 3 minus 4. Or minus 4/3. So what we could do is rewrite the middle term as 2x squared minus 4x plus 3x minus 6. So you rewrite the minus x as minus 4. Minus 4x plus 3x. Or you could have put the 3x at the front, positive 3x minus 4x. Now we factor by groups. So for the first pair of values, first pair of terms here, highest common factor there is 2x. So we factor out 2x. And then to get the terms for the bracket, we can divide each of these by 2x. So we have x and then minus 2 plus the other pair of terms. The common factor there is 3. So we divide each of these terms by 3. So we end up with x minus 2. So the common factor there is x minus 2. And outside we have 2x plus 3. Question 2b, solve the equation. So we can expand the bracket. So we have r plus 3 equal to 3 times r, that's 3r. And 3 times minus 5, that's minus 15. So we can group the like terms. I'm going to group the r on the right hand side. So I have 3r minus r. And I have positive 3 and positive 15 over here. So 3r take away r, that's 2r. 3 plus 8, that's 3 plus 15, that's 18. Divide both sides by 2. So r by 2, divide both sides by 2. So r is equal to 2 into itself as 1, so 1r. 18 divided by 2, 9. So r is equal to 9. Question 2 part C, make k the subject of the formula. So we can just keep k by itself here. So notice, so 2a can subtract 3t from both sides. So here we have 2a minus 3t equal to pi k squared. Now we want to get the k by itself, so we can divide both sides by pi. So do that. So that means that k squared is equal to 2a minus 3t upon pi. And of course now we can take the square root of both sides. So the square root of k squared, that's k. And then so k is equal to this expression 2a minus 3t upon pi. Next, a farmer plants 2 crops, potatoes and corn, on a 10-hectare piece of land. The number of hectares of corn planted, represented by C, must be at least twice the number of hectares of potatoes, which is represented by P. Write 2 inequalities to represent the scenario above. So 10 here, so when you add the amount of corn and potato planted, it has to be, you have to cover less than or equal to 10 hectares. And the other inequality, the number of hectares of corn planted must be at least, so at least be greater than or equal to twice the number of hectares of potatoes. That's 2p. So these will be the 2 inequalities. Next we are shown a prism. How many faces? 8 faces. How many edges? 18. And how many vertices? 12. Vertices will, of course, will be where 2 or 1 lines meet. So this would be a vertex, a vertex, a vertex. I can count them up. The edges would be these lines here. So these are easily countable. So part B, a sports club owns a field PQRS in the shape of a quadrilateral. A scale diagram of this field is shown below. 1 centimeter represents 10 meters. So these are diagram. And we are told that the field is to be divided with a fence from P to the side RS so that different sports can be played at the same time. Each point on the fence is the same distance from PQ as are from PS. Using a straight edge and a compass and compasses only, construct the line representing this fence. So to get this line, of course we'll need to bisect angle P. And how do we bisect an angle? So compass needle at P. Compass needle at P. A swing an arc to cut both lines that form the angle P, and then where the arc, the points where the arc intersect the lines. So compass needle here again, at one point of the intersection, you swing another arc. Compass needle at the other point of the intersection, you swing another arc. And there you have your angle bisector. And you draw a line through the point of intersection, a straight line that is, to meet RS at some point. We call that point T. So this line PT would act as a fence. If you measure this line, you get about 7.5 centimeter, give or take. And we are told that a centimeter represents a meter, a scale. So the fence PT would be 7.5 meters. Actually, the scale was 1 centimeter, represent 10 meters. So this fence would actually be 75. 7.5 times 10, 75 meters. Next, we have a transformation problem. So we have an original triangle here, PQRS, and let's get larger, so it's obviously an enlargement. And we're asked to find the center of the enlargement and the scale factor of the enlargement. Let me find the scale factor first. So the scale factor of the enlargement, which we now refer to as K. So the scale factor is the length of an image side. So let me choose Q image. Our image, the length of over the corresponding side, QR. So the length of QR image will be 1, 2, that's 3 units, and the length of QR, that's 1. So the scale factor is 3. So in other words, the scale factor is 3, meaning this means that the length of each side was tripled. Now the center of the enlargement, so we extend image point to original point like this. So I can join Q to Q. So we extend, and of course we can join P image to P image to P. So we join P image to P and we extend it using a ruler, of course. And we extend Q image to Q. When I did it in a graph paper, I get this point as this point of intersection here, which is minus 4, 1. So the center of the enlargement, which we refer to as C, so center of enlargement, would be the point minus 4, 1. Question 4a, a function f is defined as f of x is 2x plus 7 over 5. Find the value of f of 4 plus f of minus 4. So f of 4, replace x with 4. So it's 2 times 4, that's 8, plus 7 upon 5, plus f of minus 4, that's 2 times minus 4, that's minus 8, plus 7 upon 5. So I end up with 8 and 7, that's 8 and 7. That's what, 15 upon 5. 15 divided by 5, that's 3, right? And then negative 8 plus 7, that's minus 1, so minus 1/5. So it's 3 minus 1/5. So that's 3 minus 1/5. 2 1/4. Or if you want to write it as improper fraction, we'll have 14 upon 5. Next, calculate the value of x for which f of x is equal to 9. Now recall that f of x was 2x plus 7 upon 5. So if f of x is equal to 9, then 2x plus 7 upon 5 is equal to 9. We can times both sides by 5. Alright, so we end up with 2x plus 7 equal to 5 times 9, that's 45. And we can subtract 7 from both sides. So 2x equal to 45, take away 7, that's 38. Divide both sides by 2. The solution, x is equal to 19. Hence or otherwise, determine the value of f inverse 9. No, we know that so let's find, we know that f of x is 2x plus 7 upon 5. So to find the inverse, we can let y be equal to 2x plus 7 upon 5. We can interchange x and y, so we have x equal to 2y plus 7 upon 5. We can times both sides by 5. We end up with 2y plus 7 is equal to 5x. We'll just cross multiply these. So 2y plus 7 equal to 2y equal to 5x minus 7. Subtract 7 from both sides. Which means that divide both sides by 2. Y is 5x minus 7 upon 2. Which means therefore that f inverse x is 5x minus 7 upon 2. It should be 2. So f inverse 9 would be 5 times 9, which is 45, minus 7 upon 2. So 45 minus 7, that's 38. 38 divided by 2, that's 19. So our solution is 19. Another way we could have deduced a solution. Remember the original function maps 19 to 9. This was f of x maps 19 to 9. So the inverse function would do the opposite by mapping 9 to 19. So f inverse 9, of course. So the inverse function do the opposite. So 9 to 19. Inverse to the opposite. Which means that if f of 19 give you 9, then f inverse 9 should give you 19. So this solution. Now in part B, we have two straight lines, L1 and L2, and we're asked to find the equation of L1. Now the equation of any straight line is given in the form y equal mx plus c, where m represents the gradient and c represents the y-intercept. In other words, c represents where the graph cuts the y-axis. So y equal mx, now m, and this is for L1. This is for L1, of course. So like this for this line, L1. Notice the gradient. The rise over the run, notice it's what, 2 over 4. That's 2 over 4, that's a half, right? But it's slope in a negative direction. Alright, it's falling, so it's a negative gradient. L2 is rising, so L2 of course will be a positive gradient. But it's fall as you move from left to right, the slope is falling, so it's negative a half x, and the constant is where the graph cuts the y-axis, which is 2. So the equation of this line is y equal negative half x plus 2, because the slope, let's put the slope here, how to get the slope? The slope, or I would say m, is a rise over the run. Notice we use the snaps of the graph. The rise is 2. The run here is 4. So we use this as the rise. This as a run, 4. But negative since the graph, the slope is falling. Next, we're asked for the gradient of L2. So this line is what we call L2. Now, we are told that L2 is perpendicular to L1. So gradient of L2 will be equal to the negative reciprocal of the gradient of L1, which would be positive 2 over 1, positive 2 and 6, right? Since L2 is perpendicular to L1. Remember, if two lines are perpendicular, then the product of the gradients should be equal to minus 1. So if you multiply 2 times minus half, you'll end up with minus 1. So the solution, gradient of L2 is equal to 2. Question 5. A group of 100 students estimated that the mass in grams of a seed, as shown in the table, the diagram below, the cumulative frequency curve below show the results. So on the vertical axis we have the cumulative frequencies, and on the horizontal axis we have the mass in grams, of course. So we are asked to find the mean. We're asked to find the mean, part A part 1. Now the mean, now notice the cumulative frequency went up to 100. So the mean would be half of the median, The median would be half of 100, which would be 50. So we draw a line, a straight line from 50 to meet the curve. We stop immediately where the graph touches the curve, and we draw the corresponding line coming down. Here, this is what? This is 3.2. So the median mass will be 3.2 grams. Next, we're asked to find the quartiles, upper quartile, lower quartile, and the semi-interquartile range. So the upper quartile, of course, is 3/4 of 100, which will be 75. So we find 75. I'll draw a line to meet the curve here. Alright, and then bring it down. So corresponding, it would cut the about approximately here. So the upper quartile will be 4.3 grams, somewhere there. So the upper quartile would be 4.3 grams. The lower quartile, that's a quarter of the cumulative frequency, which is where 25. So the lower quartile, we'll find 25, and then take it down. That seems to be about 2.3 also. Lower quartile. Right. That seems to be about 2.3 grams approximately. So the semi-interquartile range, which are also find, so semi-interquartile range is upper quartile, which is 4.3, minus lower quartile, which is 2.3, divided by 2. So semi-interquartile range is upper quartile minus lower quartile divided by 2. So 4.3, take away 2.3, that's 2. 2 divided by 2, that's 1. So the semi-interquartile range is 1 gram. Next, we are asked to find the number of students whose estimate is 2.8 grams or less. 2.8 grams or less. Let's go back to the graph. So we look for 2.8 grams. So 2.8 will be about here. So 2.8, and we bring it up, 2.8. Here, touch the curve here. And we go across. So 38. So this solution here with 38 students of estimate 2.8 grams or less. Part B, use the cumulative frequency curve above to complete the frequency table shown below. So M is between, the mass is between 0 and 2, 2 and 4, 4 and 6, 6 and 8, 8 and 10. Let's fill in these values. Now we know the total was 100. And if we check the graph, this was 48. This was 25. And if you sum all these values, you should get 100. A student is chosen at random. Find the probability that the student estimated the mass to be greater than 6 grams. So greater than 6 grams would be these two values. As this is 6 or less, so greater than 6 will be these two values. So the solution here, the probability would be 7 upon 100, or 0.07 if you want to express the probability as a decimal. So question 6 part A. Here we have a rectangle with some circles inside there. We have how many circles? 4 in each row, so we have 12 circles, each with a radius of 7 centimeters, and they fit exactly into the rectangle. Now we are asked to show that the area of the rectangle is 2352. How do we do that? Area of a rectangle. Notice here to here. So the diameter of the circle would be of one circle would be 14. So 7 and 7, this would be 7 also, so 14. And how many circles we have? 4. So 14, so 4 times 14. So the length of this rectangle would be 14 plus 14 plus 14 plus 14. So 4 times 14, what's 4 times 14? 56 centimeters. And then the width of this rectangle. So now again, let's calculate the width. Of course, here to here is also 7. So the diameter is 14. So will be 3 times 14. That's 3 times 14. 42 centimeters. So the area, length times width, which would be 56 times 42. So what's 56 times 42? 2,352 centimeters square. So next, we're asked to calculate the area of the shaded region. Let's go back to the diagram. Area of the shaded region. So there's our diagram again. Now look at the shaded region there. Notice to get the area of the shaded region, we need the area of the rectangle. And we're going to subtract the area of the 12. It's 12 circles, right? 12 circles, 4 in each row. So let's do that. So the area of the rectangle would have been 2352. Area of the rectangle minus the area of the 12 circles, right? 12 circles. So area of the rectangle was 2352 minus area of a circle. Now area of one circle is pi r square. Pi times r square. Pi, which is 22/7 times r square. So that's 7 square. And it's 12, so this is area of one circle. Pi r square. Area of circle is pi r square, right? So remember it's 12 circles, so times this by 12. So it's 2352 minus, let's calculate here. So this works out to be 1848. So it's 2352 minus 1848. We end up with 504. So that's the area of the shaded region. In part B here we have a triangle. Notice the opposite angles 52 degrees. And its opposite sides will also be equal. So what type of triangle? This is what we call an isosceles triangle. So angle P and M, notice, remember the sum of all angles in a triangle add to 180 degrees. So notice these two angles add to angle P and angle M, that's 104 together. So the value of angle P and M would be 180 minus 104, which would be, angle P and M would be 76 degrees. This angle would be 76 degrees. Next, we're asked to find the area of the triangle. The area of the triangle, we can use the formula half AB sine C. So in this case, it's half times any two sides. We're using these sides, 12.5 times 12.5. So 12.5 squared. Sine the angle formed between these two sides. So sine 76. So we end up with 75.80 centimeters square. Now in 7a, we were asked to study the pattern and complete the table. Now the pattern I'm noticing, notice the figure, to move from the figure to the number of sticks, multiply by 12, so 1 times 12 gives us that, 2 times 12, 24, 3 times 12, 36, 4 times 12, 48, and then the number of dots, we simply add 1 to the number of sticks. Alright, so we're asked to complete this row. So to get the number, of course, the number of dots would be 1 more than the number of sticks, so that this will be 157. And then to move from the number of sticks to the number of figure, we can also divide by 12. Or, well, 5 times 12 in this case would be 60. So this would be 61. And then we could divide 156 by 12 to get the number, to get the figure. 156 divided by 12, what's that? It's 13. Notice 13 times 12 will be 156. And then the general rule here. So n, so this would be 5n. The number of sticks will be 5n. And the number of dots, of course, is 5n. It's 12n, my bad. Actually, to move from the figure to the number of sticks, it's 12n, so 12 times n. And this is 12n. Plus figure 7 and figure 8. Remember the relationship between the number of dots. Right, it's 12, so it's 12 times 7 plus 1 plus 12 times 8 plus 1. So 12 times 7, that's 84, 84 plus 1, that's 85, and 12 times 8, that's 96, plus 1, that's 97, so 85 plus 97 gives us 182. And part 2, the number of dots in figure n and figure n plus 1, again with 12 times n, plus 1 plus 12 times n plus 1 plus 1. So the relationship between the dots and the figure is 12 times the figure plus 1. So let's see if we can simplify this a little bit. So 12n plus 1, we expand, we get 12n plus 12 plus 1. So grouping the n, we get 24n. And grouping the constants, 14.